In this video, I'll be working through the questions you see on the screen, and this question's from the winter edition of Cambridge International Exams from 2023 from paper 1-2. If you want any other questions from this paper, there should be a link to a playlist in the description below. I do these on a whiteboard, hopefully to mimic how you're used to watching your teacher teach these questions. And if you find any of this useful in any way, please like, subscribe, and even share it with some friend that's doing the exams or someone doing it next year. Question 9, while difficult, is a fairly common question. They give us two lines, which I'll draw in now. This one would be the higher of the two lines. It looks like that. And then the other line starts above it but comes down below and then comes back up above like that. And that gives us two intersection points, A and B. So as I was saying, this is quite a common question, something like this, where they ask us to find the points of intersection of two equations and then ask us to find the area enclosed between the two curves. What makes it a bit more difficult is what the functions look like. Y is equal to 3 times x to the power of minus a half plus 12, and the other one has something similar. Just have to be careful when we're dealing with it. It works just like any other question. Just have to be a little careful with all those powers, fractional powers and negative fractional powers even. So let's get started with part A, where we have to find these intersection points. And as always, if we have equations like this, we can just put them equal to each other. They have y equals and y equals. So the left side's already equal at some point. So we can put the right hand sides equal to each other. Now I'm going to write them a little different. Instead of 3 times x to the power of a half, let's put it as 3 over x to the power of a half, because that's what the minus does. And then plus 12, and that will equal on the other side 2 times x to the half, that wasn't a minus, plus 13 over x to a half. That should give us a clue on how to get rid of some of this. We can just multiply everything by x to the power of a half. That one will disappear, we'll get 3, 12 will end up being multiplied by x to the power of a half. Equals, now x to the power of a half times x to the power of a half just becomes x, or, which will become useful in a moment, we can think of it as x to the power of a half squared. Anyway, this one will just disappear, so we get 13. If we clean all that up, and I'll bring everyone over to the right hand side, we'll get 2x minus 12x to the power of a half plus 10 equals 0. Now, the trick here is to notice that this is actually a quadratic. We're used to seeing something squared here, something and a number. And that's what we have. We have the something in this case is x to the power of a half. That squared is right here. So we have something squared, something and just a number. This is a quadratic. We can go ahead and factorize that. I think it works out, oh, you know what we can do first? We can divide everything by 2. So it just becomes x minus 6 x to the power of a half plus 5 equals 0. And we can go ahead and factorize that one. It just makes it a little easier. Has to be x to the power of a half times x to the power of a half. And it would have to be 5 and 1. And we need to get to minus 6, and so that'd be a minus 1 and a minus 5 would get us there. And they would multiply to get 5. So that would become x to the power of a half equals 1, and x to the power of a half equals 5. One final thing, they asked for the coordinates. So one final thing, well, two final things, sorry. We need to square this. X is equal to 1, and x is equal to 25. And still, you're going to lose 1 mark for this because they asked for the coordinates of A and B. So we need to put in the y part. What's y equal to? We take either one of these we want. I'll use the first one. I think it'll probably look easier. 1, put 1 in here. 1 to the power of anything is 1. So it's just 3 times 1 plus 12. That's just 15. That one's quite easy. Put 25 in here. x 25 to the power of a half is 5, and then the minus will be over 5. So this becomes 3 over 5. That's what putting 25 in here does. Square root of 25 and divide it. Square root of 25 divided plus 12. Let's clean that up. We would get, let's see, 5 times 12 is 60, so that'd be 63 over 5. And that'd be our answer. I like to put these together usually. 115. I'd do it down here if I had room. 115 and let's see, 25, 63 over 5. There are our 2 points A and B. Actually, which is which? So this one here must be 1 and this must be 25. The heights are, so 15 is here and this one is, what's that, 12 and a bit is down a bit lower. Okay, that answers part A. I'll clear off a lot of this. Yeah, I don't need any of that. I just need these two numbers really and these two equations to do part B. Okay, for part B, we need to find the area between these two curves. And to do that, we need to do integration. There's a couple of ways we can think of this. We could find the area beneath the higher curve and then the area beneath the lower curve and take them away. That'd find the answer. That's how a lot of people do it. Or how I like to do it is just I get the area of so the area of the curve of this in between bit is the integral of the higher line, which is 3x minus a half plus 12 minus the bottom one. So that's minus 2x power of a half. So I'm taking this one away. Minus 13. Really, you can think of this as integrating, you can think of this as taking away the integral before rather than after. It should work out identical, especially in an easy one like this where it's each term can be integrated separately. So really this is the integral we have to do. We have to do it between 1 and 25. Between 1 and 25. So let's get to this. Nothing's too complicated here. It's all normal enough integration. The first term here becomes, we add 1 onto this power. Adding 1 onto that gets to the power of a half. And then the 3 was out front. 3's out front and we end up dividing by a half. 3 divided by a half is 6. This has an x to the power of 0 here that we just don't see. Add 1 onto that. It just becomes 12x to the power of 1. Again, we don't write the 1 in either. Next one, let's add 1 onto the half. We get 3 over 2. 2 multiplied by 2 over 3 is 4 over 3. And there was a minus there. Again, we add 1 onto this and we get x to the power of a half. 13 multiplied by 2 or 13 divided by half, same thing, is 26. And again, there was a minus here. And then we evaluate, let's put a bracket around all that. We evaluate this between 1 and 25. Let's do that up here somewhere. So this area is equal to, we put 25 in everywhere. So that's equal to, I'm going to have to take 2 rows to do this. Anyway, we put in 25 is 6 times 5. Plus, so I put 25 in here, plus 12 times 25, minus 4 over 3 times, what's this? This is 25 to the power of 3 over 2. Check on a calculator. But 25 to the power of a half is 5. That's 5 to the power of 3 is actually 125. I'll continue on here. Minus, this is 26 times 5. Then we're going to evaluate 1. That means minus this when we put 1 in. It's minus 6. 1 is quite easy to put in, so 0. Minus 12. That's 1 in here. Minus minus, this will get a plus. And that'll be 4 over 3. And minus minus here will get a plus 26. Now, you can go ahead and put all this on a calculator. I'll take a quick edit to check if all these numbers are right. They do seem to be. If you put all this into a calculator or do it all by hand, you should get 128 over 3, which is, yeah, it's the final answer to question 9. So if you have any follow-up questions, anything I did there, put them in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.